In this slide, we see a UML diagram capturing the edible interface that the author gives as an example. You're familiar with the notation for inheritance, and you can see that it's used in parts of this diagram, but it also occurs with a new twist to it because we have a dashed line instead of a solid line, and I'm talking about between fruit and edible and between chicken and edible. The fact that the line is dotted or dashed captures that this is not inheritance, but rather this is implementation. So here we would say fruit implements the edible interface, and we would say chicken implements the edible interface. All of those solid lines that you see represent inheritance or extension. So in other words, we could say orange inherits from fruit, or we could say orange extends fruit, and likewise apple inherits from fruit, chicken inherits from animal, and tiger inherits from animal. Notice that consistent with abstract methods in abstract classes, we use italics in the case of an interface to capture both the name and the methods. So we have one method in the edible interface, and it's an abstract method, and it's called how to eat. Because it's an abstract method, there's no implementation here, which is why we say fruit implements the edible interface and chicken implements the edible interface. What we're effectively saying is that it provides an implementation for that abstract function, how to eat. Over the next 4 slides, we're going to talk about how the UML diagram in the previous slide would be implemented, starting with the interface. So here you can see where we've declared the interface. We said public interface edible. The comment is describe how to eat because that's the purpose of this abstract function. There's no implementation here. It's effectively a placeholder for an implementation in classes that implement the edible interface. So what we say is public abstract to make sure that it's an abstract method, and it's going to return a string, and the name of the method is how to eat, and it takes no parameters. And we go straight to a semicolon because it is an abstract function and there is no implementation present here in this slide. On this slide, we have an abstract class representing animal. So in other words, it's not a concrete class, it doesn't represent a particular animal, but it captures the notion of an animal. We have a private method, or rather data member called weight, which is a double, and then we have a getter for that data member called getWeight. There's also a setter below that called setWeight. And finally, we have one method which is abstract, and it is sound. Obviously, this is going to represent somehow the sound that the animal makes in the form of a string which gets returned. No implementation appears here, so therefore it is an abstract method which must be implemented by classes which are subclasses of this superclass. Next, we have two concrete classes which inherit from the abstract class animal, starting with chicken up at the top. So class chicken extends animal and implements edible. Now, in order for chicken to be a concrete class, it must implement all the abstract functions, or methods rather, that exist in animal, and it must implement all the methods that exist in the edible interface. That implies that it's going to have to do some overriding. We can use the @override to indicate to the compiler that we believe we are overriding a method somewhere else. And if that's not the case, it will warn us that we in fact aren't. So the how to eat method in edible was not implemented there. It was abstract, and here's where we make it concrete. So we have a method public string how to eat, and notice that it has to have the same return type and the same method signature in order for it to be an override. And that's exactly what we saw in the edible interface. So indeed we are now overriding the implementation, or the lack of implementation, that was in the edible interface. And we provide an implementation here. The implementation simply returns the string chicken : fry it. And that's all it does. Next, we override the abstract method for sound in the animal class, and we do so by returning in a string chicken : and what a chicken says. That completes our chicken class. Moving down to the bottom of the slide, we see where we now make a concrete class for tiger. So class tiger extends animal. We're now going to override the abstract method sound that was defined in the abstract class animal by providing an implementation for that returns the string tiger roar. Notice that the Tiger class does not implement the edible interface. We haven't said that it does, and in fact it doesn't, implying somehow that tigers are not edible. Continuing on with this example, then, we have the abstract class fruit, which implements the edible interface, implying that all fruits are going to be edible. We've left out all the implementation details here. Next, we have the concrete class apple, which extends fruit. Because fruit implements edible, therefore apple, since it extends fruit, must also implicitly implement the edible interface. Therefore, if we don't want apple to wind up being an abstract class, we better make sure we provide a concrete implementation for the method how to eat. We're actually going to put @override to make it clear to the compiler that that's our intent, and then we provide the implementation for the edible interface for the method how to eat. So we say public string how to eat, and we return apple : make apple cider as a string. The very same story exists with our class orange. It extends fruit and therefore implicitly implements the edible interface because fruit does, and therefore we need to provide an implementation for the how to eat method, and we do that by returning the string orange : make orange juice. So to wrap everything up, we now have a program to test what we've done. We start by making ourselves an array of objects called objects. Notice this is going to be the object class that we're declaring objects to be, or more properly an array of objects. We're going to set that equal to new tiger, new chicken, and new apple. Those are all different objects, but they all ultimately inherit from the object class. Therefore, we can say that ultimately a tiger object is an object, and a chicken object is an object, and so on. So this is perfectly legal to do what we've done here in this line. In a for loop now, we're going to iterate through our array of objects, and for each of these objects we're going to check to see if it's an instance of edible or not. If it is an instance of edible, then what we're going to do is we're going to print the string how to eat that goes with that particular object. Notice what we have to do to make that work. First, the object class does not have a how to eat method. For sure it doesn't, because the author concocted this for an illustrative purpose, so we know that's not a built-in function in Java. Therefore, we certainly are not going to be able to say objects sub I dot how to eat. Rather, we have to cast it as edible first, because edible does have the method how to eat. So we've got the cast edible in front of objects sub I, and then an extra set of brackets to enforce the correct order of operations, so that we can now take that final result and add to it dot how to eat. In the next line of code, the next if statement, we check to see if objects I is an instance of animal. If it is, and only if it is, then we're allowed to do a print line of animal as a cast objects I dot sound. So notice again how this is working. There is no sound method in the object class, so we can't simply say object sub I dot sound, even though that's the actual type for object sub I perhaps, but rather we have to first of all make sure object sub I really is an animal, it's an instance of an animal, and if it is, then we're allowed to cast it as an animal, which we do next, and then we again enforce the correct order of operations with the extra pair of parentheses before the dot, and finally we say dot sound. The output that will be generated from all of this is tiger : roar, chicken : fry it, chicken : and then the sound a chicken makes, and finally apple : make apple cider. It's a very nice example in the sense that it illustrates how we can use that instance of operator to decide which things do and which things do not apply in each case to each object.